Let's run through some of the most common questions from the second part of 3.3. Here you got a natural logarithm example. It's got it needs to be condensed. It's fairly lengthy right now. So I would start in the parentheses and look at all these logarithms that are together. Remember, logarithms are exponents. So if exponents were getting added, the bigger numbers would have been multiplied together. And if logarithms are getting subtracted, the bigger numbers would have been divided by one another. So that's where I'm going to start. One thing I'm also going to do, and I'll just kind of do this right now, I'm going to move that 2 up to an exponent right here, because that's one of our rules. We know we can do that. We proved it. So I'll keep the 1/3 out front. I'm going to go ahead and combine this as one big logarithm. So that means that x plus 3 squared will get multiplied by x. And for now, I'm just going to leave it that way. You can expand it, but there's really there's not going to be any advantage to doing that, so I'm just going to leave it that way for now. And since this is a minus, this term is divided, or these are divided by that term. So x squared plus or minus 1 would go on the bottom. And then you've got this 1/3 to deal with. So this is an additional exponent. Close that off. So now it becomes log x times x plus 3 squared over x squared minus 1, and all of this stuff is to the 1/3 power. And I think the book actually put it underneath a cube root or a radical. So these are both okay. I'll go ahead and just kind of write it out that way like the book did it and circle it. So you can see both of these are good to go. So again, all they really did is they said, all right, 1/3 power, let's turn that into a cube root. And they just wrote everything else the way it already was. And they left it right here. So either one of these is fine. I would take either one on a test or a quiz. They're pretty much equivalent in my book, so that's good. Good either way. Now 95, log base 4 of 16 to the 3.4. So what I would start with, since this is raised to an exponent, I'm going to go ahead and move it out front. So 3.4 times log base 4 of 16. Now keep in mind, this is not the only way to go about it, just this is what I would prefer to do, and it's all what you prefer. Now, always look to see if this number is a power of this number. If it is, this is a lot simpler, and 16 is a power of 4. Now if it's not, then you start looking for change of base formula, see if you can use that to condense it down. But I don't think we're going to need to do that because 16 is a power of 4. 16 is 4 times 4, so 4 squared. So let's rewrite it that way. 3.4 log base 4, and instead of 16, I'm going to say 4 squared because that's what 16 is. And one of the rules we've been using for a while now, if you have log base 4 of 4, that 2 can come out front, or think about taking the 2 and multiplying it by the logarithm out front. So that 2 gets multiplied by that 3.4, so 6.8. And log base 4 of 4 is now gone. They neutralize one another. So final answer, 6.8. On 97, you have log base 2 of negative 4. There's not a whole lot really to do here. This is a case you just want to be able to recognize that it's impossible to do, and basically there's no solution. Now, if you don't recognize that right away or understand why, let's come up with the same sort of approach we've been doing to work these out. So let's say it equals something. And let's try to figure out what that something would be. So if you rewrite this as an exponential, 2 to the n would equal negative 4. So now let's play the game. What can we come up with for n that's going to lead to negative 4? So what power of 2 would lead us to get negative 4? Well, 2 squared equals 4. But if I raise 2 to a positive power, it's just going to keep getting bigger. It's not really going to go to negative 4. 2 to the 0 power is 1. Maybe I should write some of these things down. 2 squared is 4. 2 to the 0 is 1. So I'm pretty confident there's no positive number or 0 I can raise 2 up to and get negative 4. It's not happening. And really, the only other thing to think about, what if I do maybe 2 to the negative 2, just to throw it out there? That's 1/4. It's not negative 4. And what's going to happen if I raise 2 to bigger negative numbers is this just becomes 1 over a bigger and bigger number on the bottom. So as 2 gets raised to negative infinity, the answer is going to approach 0, because it's going to be 1 divided by a really big number. So the point here, and hopefully we've touched on this a few places now, you can't raise 2 to any power and have the result come out to be 0 or negative number. Note this is approaching 0. It never actually makes it there. There's no power of 2, or you can't raise any number to a power and make it come out to be 0. It's just not going to happen. So there's really no value for n that can be used here, so, or at least no real number. So this one's just, I would just go with no solution. It can't be done. It's impossible. And finally, we have log of 1 over the square root of e. So right away, I'm seeing log of something divided by something else. So I want to expand that and say log 1 minus, because these are divided, log, and instead of square root of e, I'm going to go ahead and say e to the 1/2. So I did a couple things there. I'm seeing these are divided, so their exponents or logarithms are going to be subtracted. And I've got log 1 minus log square root of e. And I wrote square root as e to the 1/2. So again, this is a case now you should be recognizing as being possible, but it's 0. And again, if you're not sure about that, here it is off to the side. Log 1 equals, let's say, n. Okay. Well, natural log is log base e, so that would be e to the n equals 1. The only thing that's going to make that true is if e is raised to the 0 power. That's the only way we're going to get 1 as the outcome. So log of 1 is kind of a special case, and it's always 0, guaranteed. There's no exception to that. And this one's kind of using your rules. 1/2 can come out front, and log of e just neutralizes. They basically become 1. They go away. Another way you can look at it as that other rule we used where these kind of cancel each other out, and all you're left with is 1/2. But either way, that's where you get to. 0 minus 1/2 is negative 1/2. And that's as far as we can take it.